During the process of translation, the ribosome moves toward the poly-A end of the mRNA. Codons of mRNA match the anticodon of a charged tRNA, which carries an amino acid that corresponds to the recognized codon. Multiple amino acids bind together to form a protein. This translation is equivalent to translating a code into a statement that has meaning. If your parents are anything like mine, they will use shorthand to write notes to either convey a message or request for a task to be completed. Let's assume that the shorthand that my parents use is the one-letter amino acid codes. In this example, my parents work together to generate this note. My mother calls out the coding strand of the DNA to my dad, and he is responsible for transcribing the mRNA sequence and translating that sequence into the one-letter amino acid codes. I use these codes to determine the message that my parents are trying to communicate. These single-letter amino acid codes are associated with words commonly used in notes. In this original example, we have our mRNA sequence shown with one-letter codes corresponding to the amino acids listed below. The mRNA sequence is the same as the coding strand of DNA, with U's for uracil substituted for the T's for thymine. If we look at this note and connect the one-letter codes with their associated words, we can decode the message.
UGA codes for a stop codon, so the rest of the sequence
Isn't helpful for this note. If my mom were to incorrectly state one base in this sequence, that would result in a point mutation. Point mutations occur in DNA and can result in a variety of effects at the protein level. In mutant 1, we can see that rather than a C, my mom substituted a T, which caused my father to write down a U. This change in base is a transition since both cytosine and thymine are pyrimidines. The codon changes from AAC to AAU, which can be seen here. It still codes for the same amino acid, which is asparagine, represented by N. This results in the decoded message remaining the same, meaning that this point mutation is silent. In mutant 2, we see here that rather than a G, my mom substituted an A. This change in base is a transition since both adenine and guanine are purines. The codon changes from UGG to UGA, which results in a premature stop codon. This nonsense point mutation changes the decoded message to please exclamation point, since the stop codon comes a lot earlier in the sequence than it's supposed to. In mutant 3, we see here that rather than a G, my mom substituted a T, therefore my father wrote down a U. This change in base is a transversion because guanine is a purine and thymine is a pyrimidine. The codon changes from GCU to UCU, which changes the amino acid from alanine to serine. This results in the decoded message changing from please walk the dogs today to this missense point mutation drastically changes the message. In mutant 4, we see here that rather than a T, my mom substituted a C. This change in base is a transition because the thymine is converted to cytosine and both are pyrimidines. The codon changes from UGA to CGA, resulting in a read-through point mutation. The stop codon was changed to a codon that codes for arginine, resulting in a longer protein.